Welcome. In this video, we're going to take a look at some exponential regression. So we're going to continue to use our calculator to do some regression models, but today we're going to turn from linear regression to exponential regression. So we're going to start off with this data set here, looking at the cooling temperatures of a freshly brewed cup of coffee after it is poured from the brewing pot to a serving cup. The brewing pot temperature is approximately 180 degrees. So if we're looking at this, we're first going to make a scatter plot. So we want to make sure that we put these things appropriately. So time should be our x, and temperature should be the y. Take a look at your values here, right? Our lowest value for temperature is 100, and then we go all the way up to 180. So I'm going to make a little jump on my graph here to show that I'm not going to start at 0. Sorry, you can't see that. Let's make that a little better. And then we are going to go all the way up to 180. So I'm going to count starting at 100 up by tens. And that way we should get all the way up beyond that 180 that we're really looking for, right? Because that's our largest there. Okay, our time here, we're looking at minutes. We start at 0 and we go all the way up to 50. So here I'm just going to count up by 5s so that we can get all of those in here. Okay, and then it's just a matter of plotting these points. I'm going to do that really quickly. You might need to pause the video here for a second to get all of your points in here nicely so that we can see what's going on with our graph and where these values take place. So go ahead and take the time you need to fill out your scatter plot here with the appropriate points that we have. So our graph should look something like that. So once we have that scatter plot, we're going to take a look at this. And does it appear to be linear or exponential? You haven't talked about this yet, so we don't need to worry about that. So if it looks like it's linear, right, it should look like it's following a line. So if you put a line here on your graph, it kind of looks okay here, but then we have all these points here that are going away from that line versus our exponential graph, which if you remember those from our graphs here, they should make this kind of curve. So this guy looks like it is more exponential. So then we're going to use our calculator to find our regression equation. So to do that, we're going to switch over to the TI-84. 83, 84 look the same here because the 30s don't do exponential regression. So those are great for using for linear regression, but we're not going to be able to use that for our exponential. So to do this on the 84, we're going to hit stat and edit. And then we're going to put all of our X values in list 1 and all of our Y values in list 2. So if there's something in the value, you're going to go up and highlight the list and hit clear and then enter to get rid of all of the things that are in there. Then we're just entering all of our data points into the list here. And then all of our Y values that correspond into the Ys. And then you realize you missed one. So that's not great. Let's go back and check and make sure they line up. So 0, 179.5, 168.7, 158.1, 49.2, oh, and it's all the way back there. Answer. 149.2, 141.7, And then hopefully we line up all the way down. Perfect. Okay, so you want to make sure all your points line up. It's a good thing to check to make sure they go together. So then once we have all of your data in list one, list two, important to take note where you put your X's and your Y's. You don't have to put them in list one, list two, but generally that's a good place to put them. We're going to go back to stat and over to calculate. And we want to calculate going down to this EXP reg, that's our exponential regression. So if you hit enter there, the screen might look slightly differently depending on what model you have and how old it is. But this is just asking where your X is. They're in list one, list two. Don't worry about either of those. We can go all the way down to calculate and hit enter. Then it'll get us a set of data that looks very similar to what you got for your linear regression, but it's all here on one screen. So it tells us what is our form here, y equals a times b to the x, which hopefully looks familiar. So then they give you your a value and your b value, as well as r squared and r. So r is that same correlation coefficient we were looking at with our linear regression. So this 0.98 there tells us that this is a pretty good fit, right? That's a really strong, very strong correlation for this exponential model. So let's actually put the equation here. So I'm just transferring this into, from these points here, 171, keep 2 decimal places, 0.46, that's my A, plugging in the B, 0.9, I'm gonna keep 2 there, 88 to the X. Okay, and so we're just taking that A and B value that our calculator gave us and put it there. And so when we're looking at this, we want to keep in mind those pieces of our exponentials and what they represent. So for this equation, what does A represent? A is the starting amount. So we know that for our actual data, the starting amount was actually 180, but this 171.46 is the model that fits this data. So it's a little below where the coffee actually started, but that's okay. And what does B represent? So B in this case represents the common ratio. So what we're multiplying by each time. So we could also use that to say in this case that our coffee is decreasing its temperature by 1.2%, right? That's its ratio there. So when 75 minutes have gone by, what temperature can I expect my coffee to be? So look back to our equation here. Think y is the temp and x is the time in minutes. So if I want to know when 75 minutes go by, I can just plug in 75 in for X there, and then kind of look back at your table. We should get something less than 100 degrees. So 171.46 times 0.988 to the 75th. And we get 69.31, 33 degrees, which seems fairly reasonable, right? After an hour and 15 minutes, so your coffee's probably pretty close to room temperature, which 69.33 would be a good room temperature there. So let's take a look at another example here to practice that exponential regression. So a box contains 1,000 coins, is shaken, the coins are emptied onto a table, only the coins that land heads up are returned to the box, then the process is repeated. The table below shows the number of trials and the number of coins returned in the box after each trial. Okay, so we have this table here that's not in your notes. So if you want to add that in, that would be a great idea right now. While you do that, I'm going to create a graphic scatter plot on the calculator. So another new skill. So we're going to go back to our edit, clear out my list, and put my new values in here. And next one, I got next one in here. Okay. So once you have your data in there, if you want to actually look at a scatter plot, we're going to go second stat plot and turn your plot on. And then we want a scatter plot, which is that first type. So if that's not highlighted, go there. Our X's are in list 1, our Y's are in list 2. Okay, so second stat plot, turn it on, make sure it's a scatter plot, your X's and your Y's are in the right spot. And then we have to make our graph fit what we would do on our paper. So I'm going to go to Window after I put out of there. And change our X-min, X-max to match our trials here. So I'm going to go from 0 to 10 because that fits our values there. And then our Y-min, Y-max to match here. So I'm going to go from 0 up to 1,000. And that should give me a good graph of those points there. Can't quite see that last one, so we might want to change our window. I'll let it stop thinking. Slightly to go from maybe like -5, just so we can see on that side of it, -1, and up to 1,100. Okay, so you can see that point there, that's actually on your axis. Okay, so once we have our graph here, then you can take a look at it and say, okay, what does this look like? And hopefully you can see there that like we are not linear, right? It's tapering off at the end. So exponential would be a good model for this. So graphed it, we did it, check. Okay, does the graph appear to be linear or exponential? It'd be a good idea to put a little. It appears to be exponential. Okay, so we're going to use our exponential model. So quit out of your graph, second quit to get back to the main screen. Go back to our stat, calculate, all the way down to exponential regression, list 1, list 2, and calculate. Okay, so we get this y equals, our A is 1018.28. And then B here is 0.597 to the X. Okay, so here this is saying that we have 1,018 to start. We know we actually only have 1,000, but this is the model. And then we have a decay of a little under a half as we're putting those back in. So use a regression equation to predict how many coins will be returned to the box after the 8th trial. So remember, X is trials and Y is the coins. So we're just going to plug into our model here. 8 for our trials, and then actually use that. So 8.28 times 0.597 to the 8th. And we get 16.43, but these are coins. So 16 coins is what we would expect. We can't have a partial coin. And we might say, okay, we're to this 0.4, so we've gone past 16. So I would actually accept 17 coins for this as well. Depending on your rounding, right? Rounding, technically, we're going to round 4 down. But when we're looking at whole numbers, we've gone past 16. So sometimes we'll bump that to 17 coins there as well. Okay. So that is all I have for you this video. Thank you so much for watching.